Hello and welcome to my channel, The Blessed Physicist. In the previous videos, we have talked about generalized notations which included generalized displacement, velocity, acceleration, momentum, force and potential. In this video, we will be starting with principle of virtual work, which is a very important topic of classical mechanics. Before I start with this topic, please subscribe to my channel and don't forget to press the bell icon. Okay, now let us study the principle of virtual work. Now consider a system of n number of particles which is in equilibrium. By equilibrium, we mean that the sum of all the forces on the system is equal to 0, which means summation Fi is equal to 0. We know what is work, but what do we mean by virtual work? Now, consider a infinitesimal change in the coordinate del Ri. That means the change in displacement is del Ri, but this change is done with no change in time. That means the displacement is virtual displacement. It is not real because the change has not been done with respect to time. Also, these changes are done consistent with the constraints. You will get to know the meaning of this consistency in a minute. Now we have considered a virtual displacement. If we take dot product of that virtual displacement with this Fi, then Fi dot del Ri will be equal to 0. This is known as virtual work. We know work is integration of F dot dr, or we can write it as summation F dot dr. So but here in this case, this displacement is virtual displacement, hence this expression is known as virtual work. Now what we are going to do is we are going to get to the expression of Fi. Now what is this force? We are going to separate this force as the sum of the applied force Fia and the forces of constraint small fi. Now putting this expression of Fi back to equation 1, what we get is summation I Fia dot del Ri plus summation I Fi dot del Ri is equal to 0. Now I just said that the changes in virtual displacement are done consistent with the constraints. That means the virtual work done by the forces of constraints along the virtual displacement must be 0. So summation I Fi dot del Ri is equal to 0. So coming back to our original equation number 2, we have this second term equal to 0. So we are left with only first term. So what we get is summation I Fia dot del Ri is equal to 0. This is the principle of virtual work. Now what is principle of virtual work? That when the system is in equilibrium and the virtual work done by the forces of constraints is 0, then the virtual work done by the applied force will be also equal to 0. By the knowledge of this topic, we are going to study D'Alembert's principle, which is very important from exam point of view. We are going to derive Lagrange equation from D'Alembert's principle. Also, we are going to solve a lot of numerical based on Lagrange equations. So we are done with principle of virtual work, and in the next video we will be studying D'Alembert's principle. And before you leave, don't forget to subscribe to my channel and press the bell icon.